In this next chapter on relationships, we are going to move away from true relationships and step into the world of fake relationships. Now, first off, you need to understand that in a true relationship, basically the example of which, the sole example of which, is a parent child relationship. You have a scenario where the parent controls all the attributes of a child, which means the parent is controlling the child's translations, rotations, scales, visibility, everything. In most cases, this is rather excessive and unwanted. In most cases, while you're rigging objects, you want certain attributes of objects to be controlled, whereas the others to be left alone. This demands having other sorts of relationships wherein the controller is controlling only certain attributes of the controlled, making this relationship a little more convenient. Now, let me give you an example of a real life fake relationship. It's something like the relationship between you and me, if you will. Okay, I don't get to tell you what to wear, I don't get to tell you when to go to bed, but I certainly get to control a small, say, academic part of your life. Okay, so this relationship is made for convenience. It is very particular in its nature, and it's not a real relationship, if you will. I mean, it's not made out of blood or anything like that. And that's why this is not a true relationship. It is a fake relationship. It can also be termed as a boss subordinate or a boss employee sort of a relationship. Okay, so remember, fake relationships are not like parent-child relationships. They're more like boss-employee or boss-subordinate relationships. Okay, there are so many different kinds of fake relationships that Maya allows us to use that we have to actually start out with some of the more basic ones. Okay, so to begin our adventure into this world of fake relationships, we are going to start out by understanding about a set of fake relationships, a class of fake relationships called as constraints. When you hear the word constraints or constraint, I instantly want you guys to think that it's a fake relationship. Okay, so to access constraints, make sure that your drop down menu is set to rigging. If you're using 2015, set it to animation. Excuse me. Okay, so here is my constraint menu. I'm just going to open that entire menu out and keep it here. Okay, I'm going to start out with this guy right here. It's called parent constraint, and I want to start out with parent constraints because it tends to confuse people, because we just learned about a parent-child relationship. What is a parent constraint? Now remember, as soon as I say the word constraint, I want you to think of it as a fake relationship. A parent constraint is not the same as a parent-child relationship. It is a fake relationship which tries to copy a parent-child relationship. Okay, so let's say, for example, I want to establish a constraint between these two objects. I want this guy to control this guy. In a true parent-child relationship, we selected the child first, then the parent. In this particular case, because it's a boss-subordinate relationship, we have to ask ourselves who's more important to the company. Is the boss more important, or is the subordinate or the employee more important? Well, the answer is the boss is always more important, or at least that's what they told me. So in this particular case, while establishing fake relationships, we'll always select the boss first, then the subordinate. Okay, and then I'm going to go ahead and install a parent constraint. Now I want you to see how the object behaves. First off, you see that the cone is not listed inside of the cube. It's actually listed at the same level of the cube in this particular case. There is no family tree that is being formed, and that's because this is not a real relationship. I mean, it's not a true relationship. It does not change the hierarchy of things. Secondly, let me select the object. That's fantastic. Translations are certainly being controlled. Rotations are being controlled. Scale is weird if you actually see how the scale works. So this relationship, it seems to be so that scaling the boss pushes the subordinate away, but it's not scaling the subordinate. Also, hiding the boss doesn't necessarily hide the subordinate. So why is it that only translations and rotations are being controlled properly? And the answer is by selecting the cone, you're looking into the channel box, you'll know exactly what's going on. Okay, now this right here, what you're seeing on the right hand side is very, very interesting. Okay, firstly, you need to know that most fake relationships will install a sort of a color in the channel box. If you're seeing blue here, blue is the color of constraints. Just by looking here, I know that my cone is now being controlled by a constraint. The translations and the rotations of my cone are being controlled by a constraint. That is exactly what's happening. Okay, and I know it's a constraint because the color here is blue. Okay, so we're going to start identifying fake relationships by the color that they install in the channel box. Okay, this is going to be integral to understanding or identifying relationships. Great, so you can see that a parent constraint kind of tries to simulate a true parent-child relationship, and it's successful when it comes to translations and rotations, but with scales and visibility, not so much. Okay, so that's interesting. What is also interesting to know is just as the cube is controlling one cone, you can have multiple cones around the cube, and the cube can actually control all these cones, just like a boss can control multiple employees. Well, that's fantastic. Okay, but here's the interesting thing. Okay, just as you can have a job in the morning and a different job in the afternoon and a completely separate job in the night, and so in that at different times you're controlled by different bosses. A fake relationship such as constraints can allow for something like that to happen. Remember when we were speaking about parent-child relationships, any given object could only be parented to one object, is that right? It could have only one parent. It couldn't be parented simultaneously to two different objects. That's different when it comes to a fake relationship such as constraints. You can have multiple cubes, and these multiple cubes can actually control the cone simultaneously. Not only that, you can actually switch influences from these bosses by keying attributes. We'll learn about that when the time comes, but for now it's important for you to know that you can have multiple bosses control the same subordinate. Now here's one more interesting thing. Okay, remember the shopping cart or the shopping mall analogy where the mom is walking around with a trolley and the baby is bouncing around in the back following the mom. Now let's try and apply that here and see what happens. Now you see that when my boss walks around, the subordinate kind of follows it. Now when I select the subordinate, it also feels like the subordinate has its own little motion, but that is not true. Because translations and rotations are already controlled by the boss, if I press S to key it, you see a green color installed in the channel box. Green means that there is a conflict of relationship. Green means, in this particular case, that an animator is trying to control this with a keyframe, but a constraint is getting this particular boss to control the translations and the rotations of the object as well. So two different kinds of relationships are now trying to control translations and rotations of this particular cone. What happens when when such a situation arises? When something like this happens, Maya prefers one relationship over the other. In this particular case, my constraint is going to be broken. Yeah? Cone's not following the cube anymore. So what that basically means is that Control Z, you cannot keyframe this particular subordinate. You cannot keyframe it. If you cannot keyframe it, it means you can't animate it. And that basically means that the subordinate just simply follows the boss. It should not be animated. It cannot be animated. If it is animated, it's going to stop listening to the boss. Right? So that means this guy, the subordinate, is going to simply follow the boss. Okay. So that is that. Here's something interesting, by the way. If you look at the subordinate, there's a crosshair which you can open up, and you should be able to see a parent constraint node inside of it. This node is what is remembering the relationship between the cube and the cone. If you select that node and delete it, that parent constraint will automatically be removed. Okay, so be watchful of that. Let me zero this out. I'm going to show you maybe one or two more examples of constraints. Okay, so let's try one more. I'm going to select the boss, then select the subordinate, and this time go with a point constraint. Okay, now see how what happened when I clicked on it is point constraint. You see the cone snaps to the position of the cube. If you don't want that to happen, just go into the option box of the point constraint and check maintain offset. I'm going to say add. And now when I look at the cone, look at the channel box, you know that only my translations are being somehow controlled by a constraint. Okay, rotations or not, which means when I translate my bus, the subordinate goes with it. When I rotate it, there is no rotational control exercised on the subordinate, which is fantastic. This relationship is convenient, it is very specific, and that's why it's a fake relationship. Let me get rid of that constraint. Let me zero these out. Let me show you one more at least. Orient constraint. Now, I've used orient constraint. I want you to try and analyze this without me having to explain it. Pause the video if you will and try and understand what the outcome of this relationship is going to be like. You're right. The cone has rotational control coming from the cube, which means when I translate the cube, nothing's going to happen. But when I rotate it, it has rotational control. So that's our first step into the realm of constraints, if you will. Some of the important constraints to know are parent, point, orient, scale, aim, and pole vector. These are all very neatly organized in 2016. In 2015, they were scattered everywhere. But these are the constraints I want you guys to read up on. I want you to certainly try these constraints out. And remember that constraints are fake relationships, and the color they install in the channel box is blue.